Welcome to the Worldwide Center of Mathematics. Today on our series, the Advanced Knowledge Problem of the Week, we have a problem discussing a force field. This week is July 4th week, Independence Day here in the United States, so we're going to try to fit in something to do with the 4th. Given this equation, y squared minus x cubed, and x to the 5th in newtons. This is the force field where x and y is in meters. So the problem asks if to calculate the work done by the force field and if it's the same for both oriented curves. So C1 is the oriented curve where y is equal to x from 0 to 1 to 1 to 1. And C2 is the oriented curve from 0 to 1 to 1 to 1, y equals x squared. So first we're going to look at the formula to calculate the work done by a force field. So this is the definition of a line integral along a oriented curve, C. So it's the force times the piecewise regular parameterization of a curve. So we'll use R to parameterize the curve C1 and C2. And this is just f of R of t times the derivative of R of t. And so since f is a force field, then this integral is going to calculate the work done by f along the oriented curve C. So first we can parameterize C1 and C2. So we can see that the parameterization is going to be, for C1, just going to be t and t as it goes from 0 to 1 to 1 to 1 along y equals x, so y and x will always be the same. And then for C2, since we have y equals x squared, we're going to have to use t and t squared. For when we plug in any value here, we get the same values for y and x here. And so now that we have the parameterization, we can go ahead and calculate the integral. So here we're just going to calculate the work done along C1 first. And so with our parameterization, we know that y squared minus x cubed is just going to be t squared minus t cubed, and then x to the 5th is just going to be t to the 5th. And then we can calculate this out. And so taking the integral of this after multiplying through, just multiplying here by the vector 1, 1, just gives us the same formula. So t squared minus t cubed plus t to the 5th. And then the integral of that is pretty straightforward. And then we're just going to evaluate it from 0 to 1. So this comes out to be 1/4, hence July 4th. And this is the 4th. So for C1, we get that the work done by the force field along C1 is going to be 1/4. And so the question asks to see if the work done on both C1 and C2 are the same. So now we're going to look at C2's parameterization with this force field. So here we're going to look at the derivative of this parameterization r. It should be r hat, just to signify C2 we're using. And The derivative of t to t squared is just going to be 1 to 2t. And so we can multiply this through. So just multiplying the vector through, we get t squared minus t cubed plus 2t to the 6th. And then we can evaluate that integral from 0 to 1. So here we can see, after multiplying through and evaluating the integral, this integral comes out to be 33 over 140, which is smaller than 1/4. So we can see that the work done on each oriented curve, C1 and C2, the work is not the same. And so the line integral does not only depend on the f and the endpoints, but it also depends on the curves as well. But that is the answer we were looking for, and hope you enjoyed this week's advanced knowledge problem of the week. This problem is actually a problem from one of our textbooks, multivariable differential calculus. So there will be a link to that in the description. And if you want, you can hang around and check out the playlist for the advanced knowledge problem of the week, and just subscribe for more videos. Thank you.